In this class, we're going to take a look at the axis of symmetry of the graphs of quadratic functions. So remember, quadratic functions make your U-shaped parabola graph. The axis of symmetry is just simply the line that goes right down the middle. Parabola graphs are always symmetrical, so we can draw a line right down the middle, splitting the graph exactly into two parts. So we'll take a look at these examples in a moment, but just to think about the theory, if you've got a parabola, let me just make one up, which goes something like, say, this guy here, then it should be perfectly symmetrical. And you can split it right down the middle using this axis of symmetry. In fact, it doesn't necessarily need to be a dotted line. Let me actually just make that a solid line, because one of the things we're going to do here is not only consider this conceptually, but we're actually going to find the equation of that line. So straight line is a vertical line. We'll chat about what implications that has in a moment. But for right now, we just want to think about the fact that that straight vertical axis of symmetry line, it intersects with the parabola at this point here. And this point here is the turning point. Okay, so that's one of the first things to get down. If you've got a parabola, it's got a turning point. The turning point is right on that axis of symmetry. And that's true for every parabola. You don't get parabolas that they go down like quite steep and then quite shallow. They're always like perfectly U-shaped, perfectly symmetrical. So basically in these questions, if you know the turning point, then you've already kind of found the line of symmetry. Similarly, well, conversely, if you've got the line of symmetry, that tells you the turning point. So the two kind of go hand in hand. So just thinking back to straight lines for a moment, if you've already seen, which you probably have, the straight line topic, then you'll know that straight lines are in the format y equals mx plus c. But if you've done a bit more with straight lines, you might know, you should know, if you've done it, that vertical lines don't have an equation in this format. Vertical lines don't obey the y equals mx plus c. They've got an equation in the format x equals. I'm so used to writing y equals, I was going to write it again, in the format x equals some number a. And all that it means is that if you've got a vertical line and it goes through, let's say for example, this point here, which is at 2. So if that's at 2 along the way, and this is your vertical line going through that point, then we just write the equation of that line as x equals 2. Just to reflect the fact that every point on that line has got an x coordinate of 2, because they're all stacked like above and below each other. So that's how we write the equation of a vertical line. X equals some number that you've got on the line. If you know the turning point then, say this turning point was at 5 along and 3 down. So the turning point is at 5 minus 3. Then in that case, we already know the x coordinate is 5. Because that point has got an x coordinate of 5, that means that all of the points on this axis of symmetry line have got an x coordinate of 5. In other words, the equation of that line is simply x equals 5. So when we come to find the equation of the line of symmetry, the general approach, or the only approach really, is to find the turning point. If we find the turning point, we automatically find the axis of symmetry's equation. In fact, we don't even need the y coordinate of the turning point. Sometimes we will only find the x coordinate, and that's good enough to then allow us to find the axis of symmetry. So the question really gets transferred from how do you find the axis of symmetry to how do you find the turning point. So I've already dealt with how you find the turning point in other classes. If you've not seen those, then maybe check those out, or you could just follow along the technique that I'm going to show here. I'm going to do it differently for these two examples, and then we're going to interpret that to get the equation of the line of symmetry. So this guy here is written in trinomial format, and so is this guy. With the first one, what we're going to do is to find the two roots. So in fact, let's do that with the second one. Let's start with a different technique for this one. So for this one, we're going to write it in completed square form. So if you're not familiar with the way to write a trinomial in completed square form, then maybe check out a class on that first. I'm not going to go through the details of that here. We're just going to assume that you know how to do that, and then we'll move on from that point. If you're not sure, follow along, and then you can kind of fill in the details yourself later on. So writing my trinomial in completed square form, it would look like x minus 5 all squared minus 25 plus 4. So if that's just sheer craziness to you, then don't worry about it. Just park that just now and you can figure it out later on. So just taking another line to tidy that up, we get x minus 5 all squared, adding those together to get minus 21. So what that tells us is that the turning point for this parabola, this quadratic function, the turning point, which we get by an interpretation of these numbers, comes out to be 5, positive 5, minus 21. Okay, so whatever number you get in here, you change the sign on it, so minus 5 becomes positive 5. This one you just pull straight down and just get that final same number. So that's our turning point. That would be like this point here. Let's actually maybe just sketch this one real quick. So just a quick rough sketch of 5 along, 21 down. Just imagine roughly where that would be, like 5 along, 21 down. It's going to be kind of way down there, probably a bit further down in reality, but you could always imagine there being a scale on there, like 10, 20, something like that. It doesn't really matter, it's just to get orientated. The parabola's got an x, well, the quadratic's got an x squared term, positive x squared term, which means that the parabola goes this way with a minimum turning point rather than being upside down. Remember that in reality, parabolas carry on forever. We only draw part of them. So these guys would carry on forever. So our line of symmetry is going through that turning point. So it's our red line here. And just by interpretation of that point, so that point was at 5 minus 21, we realize that this vertical line has to have an equation of x equals 5. Okay, so what we've done there, we've taken the original trinomial format, we've written it in completed square here, we've then got the turning point from that, and then finally from the turning point we've got the line of symmetry. So there's quite a lot of technique in that, there's quite a lot of work there. It's quite short, but there's a lot of work in the sense that there's a few different aspects to that, and you've got to be competent and kind of correct with all of them. Okay, so let's turn our attention to the other guy. We're going to do this one slightly differently. We're going to find the roots. We're then going to take the midpoint of the roots to get the x coordinate, effectively, of the turning point, but that midpoint is also just going to directly give us the line of symmetry, because remember that the roots are symmetrical about the line of symmetry, or in other words, the line of symmetry lies between the two roots. So for this one, we're going to find the roots instead. So for the roots, we let the y be 0. So we just substitute a 0 in there for y. And we get x squared minus 9x plus 18. I'm just going to rewrite that with the 0 on the other side. I prefer to have it on the right-hand side for some reason. And just going to go ahead and factorize this guy. Hopefully it will factorize. So x and an x. Yeah, this one we need a 6 and a 3 and a minus and a minus. And then we can just solve that to get our two solutions, which would be x equals positive 6 and x equals positive 3. So we can just scoot on and mark those two onto a graph. We don't really need a graph for this necessarily, but I'm just going to do it for illustration. So marking on these two root points, so one would be at 3, one would be at 6. Our parabola's got an x squared term. Well, it's not the parabola, I don't know why I keep saying that. The quadratic's got an x squared term, so the parabola would be a minimum turning point like this. So we don't really need to figure out the turning point this time, because it's good enough just to know the root. So this root was at 3, this root was at 6. In the middle of those is going to be the line of symmetry. So x equals whatever the midpoint of those two are. To get the midpoint, just add them together and divide by 2. So 3 plus 6 is 9, divide by 2, 4.5. So the line of symmetry has got an equation, x equals 4.5. So that's basically how you find the equation of the line of symmetry. So two methods really. The first method is finding the turning point using completed square form and then just making this interpretation, basically matching up the x coordinate of the turning point. The second method is finding the roots and then just taking the midpoint of the roots, and the midpoint of the roots will be the line of symmetry. If you wanted to use that to get the turning point, that would be fine, because the turning point would have an x coordinate here of 4.5 as well, And then if you need to find the y coordinate, you could do that. But for this method, you don't need the turning point, you only need the two roots. So just make sure that that makes sense. There's quite a lot going on here, and there's two methods. Practice them both, be comfortable with both. You might need to use one or the other in different question types, and then definitely check out some practice questions on this topic.